Good morning. Today we are analyzing graphs of polynomial function, which really just means that we're going to be figuring out what the graphs of various polynomials look like, which is kind of a cool thing. I'm going to graph a few of them so you can see how close our by hand graph is to what you'll see on a calculator. But it turns out that how things factor really affects what the graph looks like. And it's kind of neat to be able to predict what the polynomial is going to look like. So that's what we're doing today. I did modify the assignment just a little bit. So this is all you'll have today, and you should be able to do that, no problem. Number one here asked you to find the product. If you were going to find the product, what would you multiply together first?
The opposites.
The plus one and the minus, yeah, the bubbles that have a pattern to them.
Yeah.
Absolutely. If you have a pattern, you definitely want to multiply those together first. So this 2x minus 3 is going to hang out, and I want to multiply that sum and difference pattern together. So we would do that. X times x is x squared. We get a positive 1x and a negative 1x. And negative 1 times positive 1 is negative 1. Whenever we have this pattern, that outside and inside term, those middle two terms always cancel each other out. And so you can take a shortcut there and jump right to x squared minus 1, which is kind of handy. Now we can multiply these two things together. 2x times x cubed is 2x to the third. 2x times negative 1 is negative 2x. Negative 3 times x squared is negative 3x squared. And negative 3 times negative 1 is positive 3. That's a polynomial. Can I ask you a question about that polynomial? What is the lead term? We're interested in the lead term today. What is the lead term? 2x cubed. Very good. The lead term is 2x cubed. Now, we call it the lead term, but is it the lead term because it happens to be leading the pack? Or is there another reason that it's called the lead term? It has the highest power. Very good, sir. Yes. It is the highest power that we're interested in. And whatever has the highest power, we're going to take that, and that's our lead term, okay? That leading term tells us some really important information about the shape of a polynomial. So it's important that I can look at factors like this and say, hey, if I just have these bubbles, can I figure out the leading term without going through all of this work? Is it possible to figure out the lead term without doing the work? Yes. What do you think? What could we multiply together? Yeah, other than with an x, sure. 2x, there's another x, and there's another x. 2x times that other x gives me 2x cubed. So that's something that we need to be able to do today. Instead of doing the work, can we quickly look and figure out the lead term? Okay? So really, really important that we can do that. The other thing is that leading term tells us about the arrows on the polynomial. All right, and it turns out there's only 4 different things that the arrows on polynomials do. You've done a lot of this graphing by hand already. But now we're going to put it all together, and you're going to have to think through all the different choices. So in order to figure that out, we have what's called the leading coefficient test. So we're going to write down some information. The leading term test. The leading term test. The leading term test. It turns out that the leading term, whatever, the million different things that leading term could be, is only going to amount to 4 different choices, 4 different outcomes. So let's say that my leading term is something like 3x squared. So that's just an example, 3x squared. When I look at this, the power is an even power. That's really important. Do you know what something like an x squared graph looks like? What shape is that x squared graph? It's a parabola. Yeah. That 3 is positive. And because it's positive and has that even power, its shape is always both arms, both arrows point up. It's the same if it's positive x to the 4th or positive x to the 6th or positive x to the 8th. If it's an even power with a positive in front, always the arrows point up. I call these even arms because they match. All right? What happens, and you should write this down, just I'm not writing it for my house. You should be writing it down too. What happens if it's like a negative 1/2 x squared? We still have an even power, but it's got a negative out in front. What happens to that parabola when you put a negative in front? What do you think it does? It goes down. Absolutely, that's right. Those arrows are still even arrows. They match, but now both of them point down. Even arms with a negative point down. It's the same if it was like negative x to the 4th, or negative x to the 6th, or negative x to the 8th, or negative x to the 12th. If it's got a negative in front and an even power, both arms are always going to point down. Craziness happens in the middle, but the arrows still point down. Okay? So when we have an even power, the arms match. Either both arms up or both arms down. So what happens when we have an odd power, like positive 2, x to the 3rd? What does a x to the 3rd graph look like? We've graphed some of them already. Yeah, they're a squiggle, yeah? They are a squiggle. When it's positive with an odd power, positive, odd-powered leading term, then what happens is we start low on the left, it does some weird things in the middle, and ends high on the right. This is an increasing function. It's going uphill from left to right. I call these odd arms. They're odd. They're crazy arms. One is low and one is high. Odd arms. These odd arms are going uphill from left to right, starting low on the left and high on the right. It's the same if I have a positive x to the 5th, or positive x to the 7th, or positive x to the 9th. If it's an odd power, it had odd arms. Craziness happens in between, but the arrows still go the same way, okay? What happens if I put a negative in front? Negative 1/2 x cubed. It's still an odd power, but now it has a negative in front. What do you think the negative does to this graph? What do you think that negative is going to do? Still going to be odd arms. What do they have to do? Well, either way. They're going to switch. They're going to start up high and do some weirdness in the middle and then end up down low. High on the left, low on the right. This is a decreasing downhill function from left to right. That's why there's a negative in front, okay? And it's the same if it was negative x to the 5th, or negative x to the 7th, or negative x to the 9th. If it's negative with odd arms are crazy arms. One's high and one's low, okay? Even arms match. Odd arms go in opposite directions, okay? That's what we learned from that leading term, and we need to look at that first today to figure out what the arrows should be doing. And that's going to be really helpful when we go to try to graph. All right, so we've got even arms or odd arms. So example 1, we're going to graph the function. Example 1, graph the function. So our first function here, f of x equals -2 times the quantity x plus 3 times the quantity x minus 3 times the quantity x plus 4. What's different about letter B? What do you notice about letter B that's kind of interesting? Squared, yeah, we've got something being squared. And that would be repeating that bubble a second time, right? That's something we're going to talk about. It's called multiplicity when we have a repeat. And that causes a really interesting change in the graph. So we're going to talk about that in just a minute. Are any of these being repeated? No, they're all happening one time. Okay, so let's see what we do with this. The first thing that we want to do is find the leading term. I want to find the leading term quickly so that we can look at that and just know what the leading term is. How do we do that? What do we need to look at? All the x's, but also we got a number out in front. That's an important number. So -2, we've got an x to the first power. We got another x to the first power, and we have a third x. And if you multiply all those together, what's your leading term? -2x to the third power. Very good. There's our leading term. Is that an even or odd arms? Odd arms. Odd arms. Because the power is odd, we have odd arms. Which way do they go? Are they uphill odd arms or downhill odd arms? Downhill. Because of the negative, they look something like this. They start up high on the left and low on the right. Downhill odd arms. Okay? We're going to use that information with our arrows to help us draw our graph in just a minute. But before we do that, the second thing we need to figure out are the zeros. The zeros of the function are easy to find. We just have to take each bubble and set it equal to 0 and solve for x. How do I solve for x? Just subtract the 3. Yeah, easy to do. Can I just write x equals -3? Yeah. What's the 0 from our bubble here? X equals +3. What's the 0 from this bubble? X equals -4. Okay, zeros are easy to find. We've been doing that a long time now, right? Okay, so we've got some zeros, and all of these have what's called multiplicity 1. So I'm going to write that down, multiplicity 1. Multiplicity 1 is that power. They're only happening one time. Multiplicity 1, they've all there's only one of them. There's no repeats, okay? Multiplicity 1 means that when we draw our graph, we're going to pass straight through those zeros. We're going to pass right through. Nothing weird happens. They just pass right through. And we've done this before. Not quite so formally, but 1, 2, 3. I'm going to go ahead now and plot my zeros. So I have a 0 at -3. I have a 0 at -4. And I have a 0 at +3. So I'm writing down all my zeros. And then I'm going to look to my arrows. I know that my arrows should start up high on the left, and it should end low on the right. And what I'm going to do then is connect a polynomial through all 3 of these zeros. And at each one, I'm just going to pass right through. The first 0 I'm going to come to is here on the left, is -4. I'm going to pass straight through. in order to pass through negative 3, I have to turn around, don't I? I got to make a little turn and pass straight through that one. And then I have to pass through my third 0, and again, turn around and pass straight through and wind up with an arrow low on the left. We've done this before. And now we have to pay attention to the different outcomes that we could get. So let's see what happens when we have some repeats. So the second function, f of x equals x minus 1 times the quantity x plus 3 squared. When things are repeated, they cause very interesting changes to the graph. And this is what I like, so I think it's so neat actually. But we want to first find our leading term. Leading term. Take a second and see what you think that leading term is going to be. All right, what do you think the leading term is? X to the third. Very good. Yeah. You can imagine if I were to write this out, x minus 1, x plus 3 times x plus 3. That x plus 3 is being repeated 2 times. So there's actually an x times an x times an x. Or you can think, hey, it's an x times this x, which is being squared. All right. So we have x to the first times x squared, and that's going to give me x cubed. And it's positive. There's not a negative hanging out in front anywhere. So here is our leading term. Are these odd arms or even arms? Odd. Odd arms again because it's an odd power. Are these uphill odd arms or downhill odd arms? Uphill, yes. Because of the positive, we're going like this. Starting low on the left and ending high on the right. Uphill odd arms. All right, the second thing we want to find are the zeros and the multiplicity. So from this first bubble, x minus 1, what's the 0? X equals 1. Good. What's that multiplicity? How many? Is it repeated? No, there's only one of them. Multiplicity 1. All right, that's the power there is a 1. All right, what about this 0? What's its 0? Negative 3. And what's the multiplicity on this one? Good, multiplicity 2. Again, that comes from that power that is being repeated. Okay. Now, multiplicity 1 is a pass straight through, just like we did here, passing straight through. Multiplicity 2 is what I call a bounce. Highly mathematical term. But every time I do this lesson, I think about Will Smith and the bounce. 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 Okay, sorry. So a bounce, meaning that we're going to approach that 0 and sort of hit the axis and return. Like a ball bouncing off a wall, almost. Okay? So we can either bounce from below, or we can sort of bounce above as well. So I'm going to go ahead and plot my zeros here. I have a negative 3 and a positive 1 on my x-axis. And I know my arrows start low on the left and are going to end high on the right, just like my leading term told me to do. Now, so starting, I always graph from the left. So on this left side, I'm going to approach negative 3. What do I need to do at negative 3? Bounce. I'm going to bounce. So at negative 3, I have a bounce. So I'm going to approach from underneath on the left, and it bounces. It sort of hits the 0 and bounces off of it. Do you see how it's kind of bouncing? I call that a bounce. Now, at the 1, I have to pass through the 1 because it's a multiplicity 1, which means I need to turn around and then pass straight through that 0. And it's just a nice smooth curve. And I think that drawing these is super fun. So while you're fixing up your graph there, I'm going to show you. You can check these if you have a graphing calculator, then there's a reason. We like you to have those. But I can type in my equation and I can graph it, and you can see that, look at that. That's a pretty good by hand graph of what your calculator gives you. That's pretty neat, right? That's, we're going for good enough, right? Close enough. Really good. All right, let's try a couple more. All right, letter C, f of x equals -1/8 x minus 3 squared, x plus 1 quantity squared. The first thing we need to find is that leading term. Take a second and see if you can figure out the lead term. All right, looking for the leading term. What do you think the lead term is? Good. Yeah, we definitely have this number out in front, that -1/8. And there's an x. What's special about that x? It's being squared. Yeah, so that's an x being squared. And then here we have an x. What's special about that? It's also being squared. So we have x squared times x squared, which gives me -1/8 x to what power? 4. Yeah, x to the 4th. So here's our leading term. Is it telling us that we have odd arms or even arms? Even arms. Since it's an even power, even arms. Are these both arms up or both arms down? Both arms down because of the negative. All right, something like this, both arms pointing downward because of that negative. Craziness happens in between, but we really are interested in those arrows. So then the second step is to find the zeros and multiplicities. So from x minus 3, what 0 do we have? X equals 3. Good. What's its multiplicity?
2.
What does multiplicity 2 mean? Bounce. Very good. All right. Here we have from the x plus 1 bubble, what's the 0? X equals -1. And what's the multiplicity? 2. And what does multiplicity 2 mean? Bounce. Bounce. All right, so we have -1 and 1, 2, 3. And my arms should both be starting nice and low. So I'm just going to draw those in. I have to connect those little arrows. The first 0 I come to is at -1, and I have to bounce off of that 0. So I'm going to come on the left and hit it and bounce away. That's a bounce. It's like hitting the roof and popping back down. And then we're going to have to turn around and again bounce off the 3 and return to my arrow that points down. Which I think is pretty cool. So I went ahead and typed in this equation into the calculator, and there you go. That's a pretty good graph compared to the calculator. All right. Neato. Last one, ladies and gentlemen. -1/5 x minus 1 cubed. Ooh, interesting. And then x plus 3 quantity squared. So first we want to find the leading term. The leading term, I have about -1/5 out in front. I have an x to what power? To the 3rd. And then I have x to the 2nd. So I get a leading term of -1/5 x to what power? X to the 5th. Are these even or odd arms? Odd arms. because it's an odd power. Are these uphill odd arms or downhill? Downhill odd arms because of the negative. So we start up high and then down low. High on the left, low on the right. So 0, second step. If my bubble is x minus 1, the 0 is x plus 1, x equals 1. What's the multiplicity here? Multiplicity 3. We'll talk about that in just a second. From my bubble, I get x equals negative 3 for a 0 with a multiplicity of 2. What does a multiplicity 2 mean? Bounce. Multiplicity 3 is interesting. Multiplicity 3 is what I lovingly call the slide. Lots of dance moves in this today. A slide to the right. And so it's a little slide, just like a dance move, slide to the right. Isn't there a song? Okay, sorry. There's lots of songs. -1, -2, -3. I've got at -3, I know I need to bounce off of -3. And then at +1, I'm going to slide through that 0. I know my arms should start up high on the left and end low on the right. So I got my little starter arrows there. So I'm coming from above and I have to bounce off my leftmost 0 here. So I'm going to come in on the left side and hit that 0 and then bounce back. So that's a bounce from above. And now I have to slide through 1. So that means I got to turn around and I'm going to approach on the left side and sort of slide along the axis and then pass down below. So a slide just sort of slides through it and continues to pass through the 0. It doesn't return like a bounce. Okay, let me show you. -1/5 x. It's weird, right? It's kind of neat though. X cubed, x minus 1 cubed, and then x plus 3 squared. Okay, so I've put this equation in my calculator. And you can see pretty close there, we have a bounce at -3, and it turns around, and you can see how it sort of runs along the axis just for a second right there, and then passes through. Okay, very cool. That, ladies and gentlemen, is what we're doing today. Do you have any questions for me? All right, then you can get started on CP 74.